Hey, good Tuesday, everybody. Mr. Marquardt here with you guys again, working you through 2.3.1. So hopefully, if you guys are watching this, you're either absent or you just need a little more help and wanted another walk through the problems that we did in class today. So hopefully you fall into one of those two categories. A couple announcements. We have homework collection number 10 is going to be Friday. We had a quiz a week ago today, so if you guys haven't taken that yet, please go and do so as soon as possible. This is going to be probably missing in the grade book, I would imagine. So the game plan for today, we're going to check our homework answers. I'll put those up really quick, and then we've got to work through 75 through 80. So quite a lot to get to today, so let's get chopping. So first thing, homework answers. Again, we're watching a video, some magical things. So let's slide down. If you need to look at any of these answers, just pause the video and take a look. Or reach out to your grading teacher, or even better, go to the West MRC if you guys have any questions. Again, that Google Meet code West MRC, just like that. Make sure you type it in all together. So if you have any questions, go there, ask your grading teacher, all that kind of good stuff. But let's jump into today's last item. So 2.3.1, how can the solution help find an equation? So we talked about yesterday the big race. We had the final heat yesterday. And yesterday we were given a slope or a rate and a given point, and we had to find the equation of that line based off of those two things. So today what we want to try to do is find an algebraic method for finding the equation of a line when given its slope and a point on that line, so it's exact every single time, we don't have to guess. So that's the game plan for today. So let's jump in looking at 275. So Colleen recently purchased a farm that raises chickens. Since she has never raised chickens before, Colleen wants to learn as much as possible about her baby chicks. So in particular, she wants to know how much those chicks weigh when it is hatched. So to find out, Colleen decided to track the weight of one of those chicks that was just born before she purchased the farm. So she found out that her chick grew steadily by 5.2 grams every day. So that sounds like a pretty important number to me. So I'm going to highlight that. So her chick grew steadily by 5.2 grams every day, and she assumes that it has been doing so since it hatched. So we're assuming that it's always growing by 5.2 grams. So 9 days after it hatched, the chick weighed 98.4 grams. Again, that seems like a pretty important sentence right there. So 9 days after it hatched, that chick weighed 98.4 grams. Find out two things here. We want to figure out how much the chick weighed the day it was hatched using two different representations, one a graph and one an XY table, and then we want to find out how many days it's going to take for the chick to weigh 140 grams. So a couple questions to keep in mind. I'll ask you to pause the video here and try to think of some answers to our discussion points here. What are we looking for? What information are we given? What do you expect the graph will look like and why? And which representation, graph or table, do we think is going to give a more accurate result? So I would take a minute, think about those couple questions before you continue with that video, just to get our mind thinking about what we're looking for here. What do we actually know? How can we use that going forward? That's what we are trying to figure out as we go forward. So we're going to start, if we go to 76, by using a graph. So again, we are taking a look at 76A, what is the baby's rate of growth? That is how fast does the baby chick grow each day. How does this rate relate to the equation of a line? So if we go back to 75 in those directions, if we go back all the way at the top here in yellow, the chick grew steadily by 5.2 grams every single day. So 5.2 grams every single day. So that tells me that that is our rate of growth. Because it's growing, again, it says it in the directions there, that it's 5.2 grams each day. Each day. So that is the answer for the first part and the second part. The rate of growth is 2.6 grams each day. How does this rate relate to the equation of our line? We've been talking a lot the last couple of weeks about growth and rates, and we know that when we're talking about equation of a line, that always means one thing, and that is always our slope. So this number, this 5.2 grams, is telling us the slope of our line, because our slope always represents the growth between points on our graph. Before graphing, describe a line that represents the growth of the chick. So right now, we already know that our slope or our line is a slope of 5.2 for the growth of that chick. So every day that we go further and further and further, that chick is getting bigger by 5.2 grams. Do we know any points on the line? So we, again, go back to 75. If we go back to 75, we know that at 9 days, this chick weighs 98.4 grams. So now, looking at that direction again, that at day 9, our chick weighs 98.4 grams. So let's try to figure out how that's going to fit onto a graph by looking at part C on the very next page. So we know that if we draw a graph for this situation, we want to try to let the horizontal axis or our x-axis represent the number of days since the chick was born. So we want to also let the vertical axis be the chick's weight. So on the left-hand side here, our vertical axis, our horizontal, or our y-axis, I should say, is our grams. And our x-axis is the number of days. So if we go back to our point from the last page, we know, again, that at day 9 there, that chick is 98.4 grams. So we can write that as an ordered pair now, as since our days are our x values, our grams are our y values, it's 9, 98.4. So let's try to put that on a graph and see what that's going to put us here. So we can try to find our initial birth weight for that hat, or for the little baby chick, and then we can also find at day, or how many days it's going to take, so we weigh 140 grams. So if we plot that point, again, our first point is 98.4. So when we plot that point, we go over 9 days. So we're at 9 days right here, and go up to 98.4 to put us somewhere right there. So again, our graph, each line on here is 20 as we go up. So it's kind of hard to get very precise, so we're kind of guessing what that's going to look like. So from here, we want to try to figure out what's the y-intercept of our graph. So we don't really know that unless we try to plot some more points and figure out what this graph or what this line is actually going to look like. So again, we know that our slope is 5.2 grams per day, so it's 5.2 over 1 day there. So now we know that every time we go over to the right 1 day, we are adding 5.2 grams. So we can also do that backwards and hopefully make our lives just a little bit easier. So if we go back 1 day, so we have our slope triangle, our change in x is 1. If we go down, do that slope triangle a little backwards, then we're going down 5.2. And we put another point on that line using our slope triangle. We should be able to connect those two dots to see what our line is going to look like. So if we do that, it would look something like this, where that line is going infinitely in both directions. So we can put those arrowheads on both ends. So that's what that line would kind of look like. So if we look at part D, what's the y-intercept of our graph? Well, it looks like it's hitting at about 50, but we can't really be sure. So let's just kind of guess, because we don't really know for sure. It doesn't look like it's precise, but we'll say our y-intercept is about 50. That's what that little squiggly means, is about 50. So when will the chick weigh 140 grams as we go to the next page here? So when will the chick weigh 140 grams? That's part E. So if we know that our equation is 5.2x, where 5.2 is our slope, we're adding our intercept, which we guessed to be about 50. So let's put 50 in here. just for the sake of putting something in. So if we put 50 in there, and then we know that we want to figure out how many days it's going to be until our chick weighs 140 grams. So when we know the weight, that is talking about our Y value. So when we plug in 140, what we have to do is set 140 equal to 5.2x and then plus 50. So from there, we can solve for x. And when we solve for x, we should get our x to equal about 17.3. So it's 17.3 days. 17.3 days. So how is the minimum and the y-intercept related in this graph? If we go back and look, since our x-axis is talking about the number of days old that our chick is, I think our x equals 0 is going to be our minimum for this graph, meaning that our graph should stop. Let me change colors right here. Our graph should stop right there. So don't pay attention to that at all. Just think about it. Can we have a chick that's negative days old? I don't think so. So since our chick is born on day 0 and it can only get older if we add weight from its birth weight, we can't really count anything that's a negative x value. So our minimum is going to be where our x is equal to 0. Perfect. So I'm not sure, even though we got 17.3 days, I don't know if I like that 100%, because it doesn't seem very accurate, because we had to guess what our y-intercept was going to be on our graph. So let's try to use a table and see if we can't get that a little more dialed in to see what that's going to look like. So, or to get that y-intercept a little more accurate. So let's now switch gears a little bit, and we're going to make a table instead. So like we did for our tiles way back in at the beginning of chapter 2, so we're going to say that the top row is our x column, the bottom row is our y row, where this is again weight, and this is day. So we're going to start at day is equal to 0 and go all the way over to day 10. We're going to do 10 days worth of inputs up on top here. So then we got to figure out what the outputs are from here. So again, we know for sure, again, point number 9, because that's what was in our directions in 275. So we know that at day 9, that chick weighs 98.4 grams. So now we want to use the growth rate to complete this table. So again, our growth rate is 5.2 grams every single day. There we go, 5.2 grams per day. That's kind of messy. I'm going to rewrite that. Apologies for the sloppy handwriting there. 5.2 grams per day. That's number 6. All right, so if we want to go up to day number 10, we got to add 5.2. So that would be 103.6. If we want to go backwards from day 9, going this way, we have to subtract 5.2 from each day going downward. So day number 8 would look like 93.2. Day number 7 would be 88 grams. We would have 82.8 for 6, 77.6 for 5, 72.4 for number 4, and then 67.2 for 3, 62 grams for day number 2. Day number 1 has 56.8, and then for day 0 we have 51.6. So according to our table here, how much did this chick weigh when it was hatched? Well, we know that from all of our time talking about algebra tiles and tile patterns, that is at day 0. Our x is equal to 0, that's our initial value. So our new y-intercept is going to be 51.6. That seems a heck of a lot more accurate than just trying to guess when we're talking about just drawing a random line on our graph with trying to estimate where that slope triangle is. So 51.6 is what we're looking for there. So when will the chick weigh 140 grams? So let's before we try to figure that out, let's update our equation here. So we know that y is now equal to 5.2x plus 51.6. So now we're going to try to figure out again, when our weight is 140 grams, that 140 has to go in for y, because our y is telling us how much that chick weighs. So here, again, we plug in 140 equals 5.2x plus 51.6. I'm not going to work through every single step to get x by itself here, because hopefully we can do that, but we should hopefully get that it takes us 17 days for x, or for our chick to weigh 140 grams. So that is what we should hopefully get when we solve for x, given that equation. All right, perfect. Let's move on to 78. So finding an equation without a table or a graph. So since we're going to look at the same problem again from a different lens here. So since Colleen is assuming that the chick grows linearly, that means at a constant rate according to the equation of a line, the equation will be in the form of y equals mx plus b. So without graphing, what do m and b represent? We've talked about this 100 times, and this should be super repetitive for everybody. So hopefully we all know that m is slope and b is our y-intercept. So do we know any of these for our chick situation? Yes, we know that our slope is 5.2. And the units for that, like we talked about, are grams per day. And we're going to ignore the table that we just did. Given just the information that we had from 75, we don't know what our y-intercept is. So we don't know this yet. So that's still a big old question mark. But if we go down to part B, we're going to think about this just a little bit differently. We already know the chicken's rate of growth. We're going to put that into the equation. So we know that y is equal to 5.2x plus b. We don't know b, and we don't know x, and we don't know y. But actually, I think we do. So if we think back again, we know that on day 9, if we're given that in our directions, that our weight is 98.4, our x is 9 because it's day number 9. So if we plug in a point, for example, and if we know that we have 9 and 98.4, this is our x value, this is our y value. What if we plug in 9 for x and we plug in 98.4 for y? We should be able to solve for our y-intercept if we do that. So that's what we're trying to do on the next page here as we look at part E. I know I kind of jumped ahead a little bit, or part D, I should say. So if we plug in our y, or those values like I just had on the last page, I'm going to go to the last page because I have a little more room. But if we plug those in and try to solve for our intercept, we would get 98.4 is equal to 5.2 times 9, and then plus our intercept, which is b. So the first thing we got to do is multiply 52 and 9, so we can rewrite this as 98.4 is equal to 46.8. And then adding our variable for our intercept, which is b. Next, subtract 46.8, subtract 46.8, and we get 51.6 to be equal to our intercept. Almost like magic, but it's not because it's algebra. So this is exactly the right answer, 51.6. We found that using our table, and we just found it using algebra by just knowing the slope and just knowing one point that is on our line. So we know one point and we know the slope, we can plug it into that equation of our line, which is y equals mx plus b, to figure that out. So again, if we plug this in for our variable and try to figure out how many days it takes to weigh 140 grams, just like we did on the last page, it's the exact same process. I'll let you guys work through the rest of that one on your own. So the last thing that I want to do, I know my video is getting just a little bit long, is to talk about 279. 279. So these are the exact same problems that we just did. I'm going to do A with you in the video. Again, I know it's getting a little bit long here, and then we're going to be done from there. So first thing, we have a slope of 3. We have a point of 15 and negative 50. So this is our m value. This is our x. And this is our y. Our equation for that line is y equals mx plus b. So let's plug in what we know. Let's plug in what we know, which is m, x, and y. So we have negative 50 is equal to negative 3 times 15 plus our intercept. So from here we got to multiply first. We got negative 50. Negative 3 times 15 is equal to negative 45 plus our b value. So from here we got to add 45 to both sides. So those cancel. So negative 50 plus 45, or negative 50 plus 45 should, if we move this up to the right here, leave us with negative 5 is equal to our intercept. So if we plug that all in, we should get our final equation here to be y is equal to negative 3x and then minus 5. So I would do part B on your own. Again, that's just good practice for everybody, so take a look at that one on your own. I will also let you do 80 on your own. That's kind of a challenge problem. It kind of deals with converting meters to centimeters and all that kind of good stuff. We're trying to figure out how tall Mount Everest is in that one. Again, a good practice problem, a good challenge problem, but I'll let you guys do that one on your own. So last thing for today before we wrap up is toolkit time. So we have a couple different ways we can figure out how to find the slope of a line. Given one point in the slope, the one that we talked about the most today was substituting into y equals mx plus b if we know both the slope and a point. Or we can use this formula, which I will write over here, which is y minus y1 is equal to the slope times the quantity of x minus x1. So again, we're just labeling this point as x1 and y1, plugging those numbers in here, and then plugging our slope into that equation as well. And these will get you the exact same thing. So the equation for this line, if we work that one through, would be y equals 2x plus 9. Plus 9. So then when we do this one, we just plug in our numbers and then evaluate through. So it would be y minus 7 is equal to 2 times x plus 1. So again, then we can distribute through and then rearrange that so it looks, or solve this for y so it looks like our mx plus b formula. So we get the exact same thing either way. So that's what we got for today. I hope this helped. If you were confused, if you're absent and still have questions, please let your grading teacher know or come talk to us in the MRC. Otherwise, I hope you guys have a great rest of your Tuesday, and we will see you in class on Thursday once again.